Hello everyone. This is the continued session for the problem solving of kinematics. We are now doing the fifth question. We already did the fourth question, and now this is the fifth question. It has some links with the fourth question. Okay, so however, we will see that what we have to do in this question. So this was our fourth question, and now we have to draw the graphs of uh, dt, distance time graph, velocity time graph, and acceleration time graph for the all the data that we have in the fourth question. So our objective for this question is to draw the graphs. Okay, so let me note down all the data that we have from a previous exercise, and we will use that to draw the graph. Okay, so event 1, event 2. Okay, just to give you a brief summary of what is going on. So we have a car. The car accelerates in the first event, then in the second event it goes with a constant velocity for a certain amount of time, and then it in the third event it decelerates to 0. Okay, the time for the first event is 6 seconds, the time for the second is 10 seconds, and the time for the third event is 4 seconds. The initial velocity of the first event is 2 meter per second. The final velocity of the first event is 8 meter per second. In the event 2, since the velocity is not changing, so we can take the initial and final velocity to be the same. So we will say the velocity to be 8 meter per second, because we have said earlier that the final velocity of event 1 is the initial velocity of event 2, because when you finish event 1 you enter into the event 2. So that means that the final velocity in the event 1 would be the initial velocity of event 2. The same goes to this part. The initial velocity of event 3 would be the final velocity of event 2. So vi would be 8 meter per second, and we know from the event 3 that at the end of event 3 the car goes to rest, so that means that vf is 0. Okay, and we also have calculated the distances for each event. Let me show you. The distance for the first event S1 is 30 meters. The distance for the second event is 80 meters, and the distance for the third event is this one, which is 16 meters. Okay, now our objective is to find the velocity time graph. The first question, find the velocity time graph for this event. So we will draw a graph, okay, between velocity and time. Alright, first of all, let's divide the time slots for the events, because we know from 0 to 6 we have first event, from 6 to 16 we have the second event, because the total time is 10 seconds. And not that this is not drawn to scale, we are doing a rough sketch just to understand what is going on. And the third event is from 16 to 20. Okay, all right. Okay, so since acceleration, remember, whenever the acceleration is constant, the line of the graph, the shape of the graph is straight lines. They might be steeper, they might be horizontal, depending on the acceleration, the value of acceleration. But since we are only dealing with uniform for constant acceleration, our graphs would be of straight line type. Okay, so we know that at 0 second we have we will go for the event 1. We have vi is 2 meter per second. This is the velocity at 0 second. Okay, this is 2, and we know that at 6 second our velocity is, for the 6 second our velocity is 8, because the time of this whole event is 6 seconds, and it's also the same time at which our final velocity is determined. So at 6 second we have a velocity of 8. Okay, now you can join this point and this point to get one part of our exercise. For the event 2, our velocity remains same, constant for another 10 seconds. That means from 6 to 16 our velocity will remain constant. Okay, and from 16 to 20, this is event 2. Okay, this is event 1. From 16 to 20 seconds, for it, that means for another 4 seconds our initial velocity is 8, which is of course given, and our final velocity is 0. So this is the 0 velocity, so this is the final velocity, so it will reach this point. Okay, so this is the velocity time graph. Notice that the area under the graph, when you will find the area of this graph, you will get the area to be 126. Okay, how is that possible? Let me do a quick calculation. Okay, let's make, because it starts from here, I can make a triangle here, I can make a rectangle here, I can make a rectangle here, and I can make a triangle here. For area 1 is, since it's a triangle, half, the base is 6, and the height is from this point to this point, that is 8 minus 2, so it's 18 meters. This is area 1. Area 2 is a rectangle, so it's 2 multiplied by 6, which is 12 meters. Okay, now we have area 3, which is this area. The base is 10, 16 minus 6, 10, and the height is 8, so area 3 is 10 multiplied by 8 gives 80 meters. And this is area 4. Area 4 is a triangle, so half, base, which is 20 minus 16, 4, and the height is 8, so this is 16 meters. Okay, when you sum all these, 16 plus 80 plus 12 plus 18, you will get 126 meters. And this 126 meters is the total distance the car has covered from starting from the start of event 1 to the end of event 3. So we can conclude that area, and notice that in our previous question, which is actually the same question, the total distance we got using the formulas was 126, and the same distance we got here. So area under velocity time graph gives total distance covered. Okay, now we have to find since we have velocity time graph, now we have to find acceleration time graph for the same event. Okay, it's pretty much easier, but okay, let's see. Acceleration time graph, again divide this into the time slots, 0 to 6, 6 to 16, and 16 to 20. Okay, from 0 to 6 we know that we have an acceleration of, you can find the acceleration from here, because we have Vf is 8, Vi is 2 time is 6, so acceleration is 8 minus 2 divided by 6. This gives 1 meter per second square. So from 0 to 6 our acceleration is constant, and which is 1 meter per second. So we can say that it would be something like this. Okay, from 0 to 6. From 6 to 16, since velocity is constant, it is not changing, so this is constant velocity and it's not changing. That means acceleration is 0, so it will be somewhere here. Okay, and from for event 3, from 16 to 20, okay, we can find the acceleration here because we have vf, vi and t. So acceleration is vf minus vi divided by t. 0 minus 8 divided by 4, which is minus 2 meter per second squared. Okay, so it is negative, so we can extend this graph in downward direction. We have minus 2 somewhere here, so from minus 2 to from 16 to 20 we have a negative acceleration. Okay, so this is our acceleration time graph. All right, I think that's it. Now we will go into the final question, which is question number 6 of problems of kinematics, and let's see how this we can solve. This is the final question. Okay, the final question is about the same problem, a car. Okay, and here is the policeman. The car here has a velocity of 2 meter per second. It covers a distance d, which we don't know. The time of this event is 6 seconds. And here is the policeman, and he has a condition. The condition is such that he says that above 20 meter per second you will be fined. You will be fined. So the question is, find d such that you are sorry I'm sorry find d such that you are at the boundary of getting fined, or in other words, find maximum find maximum distance of find the maximum distance of not getting fined. Okay, so we have to find the distance such that you are not getting fined, and the acceleration for this is 1 meter per second square. Okay, oh sorry, acceleration is not given. I'm sorry, acceleration not given. All right, so first of all, let's write the data in a mathematical way. Vi, which is 2 meter per second. We have t, 6 seconds. Now the trick here is to assume our vf to be 20 meter per second, because this is our limit. Okay, this is our limit. If we cross this limit, we will be fined. Okay, so whenever you are at the boundary of getting fined, that means your velocity will be 20 meter per second. Okay, so unknown quantities are acceleration and the distance. Acceleration is vf minus vi divided by t, so which is vf is 20, vi is 2, divided by t is 6, so 18 divided by 6 is 3 meter per second square. okay. And distance, now because we have everything now, we have vi, vf, t, and so we can find the distance. I will use this equation. 2as is equal to vf square minus vi square. Vf is 20 square minus vi is 2 square, and divided by 2a, a is 3, okay, and this is s. So 20 square is 400 minus 4 divided by 6. So 400 minus 4 divided by 6, you get 66 meters. So that means that the car has to be at 66 meters so that he is at the boundary of fine. If the d is greater than 66 meters, then his velocity would be greater than 20 and he will be fine. Okay, so thank you so much. I hope you have understood everything.